Why does the brain change during schizophrenia psychotic states? Imagine your brain as a busy city with roads and signals guiding how everything works together. When someone has a psychotic episode in schizophrenia, it's like the city's traffic system suddenly gets disrupted. During these times, the brain undergoes real changes that affect how it processes information and controls thoughts and feelings. These changes happen because key parts of the brain stop working properly. One major system that malfunctions is the filter system. Normally, this system helps us focus on what's important and ignore distractions. When it's broken, the brain can't tell what's real from what's not. That's why people might see things that aren't there or believe things that aren't true. Another system involved is the predictor system, which helps us anticipate rewards and outcomes. When this system is disrupted, it becomes harder for the brain to interpret experiences correctly, leading to confusion and false beliefs. Structurally, the brain of someone with schizophrenia often shows physical changes. For example, the amount of gray matter, which contains the brain's neurons, can shrink. White matter, the fibers that connect different parts of the brain, can also decrease. These changes are mostly seen in the front part of the brain, called the frontal lobe, and the temporal lobe, which helps process sounds and language. The insula cingulate gyrus and superior temporal gyrus are also affected. Additionally, the fluid-filled spaces in the brain called ventricles tend to enlarge. These changes usually start around the first time someone experiences psychosis and can get worse if episodes happen again. These brain alterations do not happen in just one area but affect many networks that work together. For example, the striatum, involved in dopamine signaling, often shows abnormalities. Since dopamine is a chemical that influences how we feel pleasure and motivation, its imbalance can lead to delusions and hallucinations. The thalamus, which acts like a relay station for sensory signals, can also be affected. All these disruptions make it harder for the brain to plan, make decisions, and behave socially. During an acute psychotic episode, these brain changes help explain why a person might feel disconnected from reality. The impaired filtering and prediction systems cause distorted perceptions and beliefs. The physical changes reflected both a biological vulnerability and the effects of repeated psychotic episodes. If untreated, these changes can lead to further decline in brain function. That's why early treatment is so important. Medications that balance neurotransmitters, especially dopamine, can help stabilize the brain, reduce symptoms, and prevent some of these changes from worsening. Understanding how the brain changes during these episodes helps us see why timely intervention can make a real difference in managing schizophrenia.